Welcome everybody to this video. We are going to talk about seamless migration in the terms of safely transitioning your large IoT fleets to AWS. This is part one of the video. It will be a two-part video series. My name is Katja. I'm a senior specialist for database, and I have been an IoT specialist for 2 years here at the company. And I'm joined today by my colleague Andrea.
Hello everyone, I'm Andrea Sickel. I'm working as Principal Specialist Solution Architect in the area of IoT for AWS. Back to you, Katja.
Perfect, then let's dive into the agenda. Today, for this video, we are going to walk you through the start of a typical migration journey. So we're going to talk about challenges that you might be facing with your self-managed IoT brokers. We're then going to dive into the specific scenario that we lay out today to think about or dive deeper into why a migration journey might be important, and also discuss the technical requirements for the features of the new solution. And then Andrea will actually dive into the AWS IoT features that support complex migration in general and also help out with the specific migration scenario we're going to discuss today. As I said, we're going to start with the typical challenges that you might be having yourself with running your self-managed IoT broker. We worked out 4 different complexities that you could be facing. And the first one is high cost. And I'm talking here about high cost when it comes to the inefficient capacity planning, also more perhaps of the engineering resources in the company. So how do you assign those to the projects you have and balance all the needs of all the teams and all the projects and features? The second one then would be more on the compute side of things, so matching the demand with the resources. If you have an IoT workload, you will have some kind of compute underneath, some kind of EC2 instances, virtual machines, whatever. And it's very important to match this with the demand of the workload itself without over provisioning, because then you're overpaying, or under provisioning, which means that you are not able to serve the workload in the time of need. The third one that we have here is security risks. And here at the company at AWS, security is our highest priority. And especially if we talk about not only a few devices you have on your desk, but you have thousands, you have millions of devices, and you want to operate them, connect them at scale in a secure manner, that can be quite a complexity in itself. And the fourth one is slow innovation. So we talked about the complexity of engineering resources before. Now think about that you want to have your teams focused on building those future features and having the time and the capacity for this. And if you're focusing on having, for example, your broker up and running in the region that you have the highest demand in at the moment, that might be quite a big challenge. And freeing up those resources is also one of the key drivers for us today, at least, for considering a managed IoT broker solution. And thinking about that, we now want to understand the customer scenario. What is the customer architecture looking like that wants to migrate to IoT Core, and also understand the requirements? This is the customer architecture. Andrea and I actually built out this architecture looking for a more demanding architecture to migrate, so that everybody watching here today can understand that even with these complexities, we can have them migrate to AWS IoT Core. There might be other or different scenarios. For example, you see here we're using a DNS server. You might be needing static IPs and using a load balancer in between. That's also something that can migrate. But as I said, for today, let's look at this scenario, but just keep in mind it's not the only scenario that can migrate to IoT Core. We're starting on the very left. We have 10 million devices that are connecting daily. They are connecting to an on-premises solution for our broker and the backend services. They leverage DNS server connecting to the self-managed MQTT broker. And from there on out, we have roughly over 80 backend services, and these are arbitrary numbers. We just needed something for us today to discuss and walk through the scenario. So around about 80 backend services, and each of these backend services has 20 to 100 different instances. From there on, we have the API gateway and some kind of consuming applications that interact with these backend services. This now brings a good overview about the architecture. Let's look at the actual technical requirements that a new solution also would bring. Number one, again, starting on the very left, our devices, our over 10 million devices, are connecting from all over the country, from all over the world. We have no options to go to them manually and operate them or change something. And we really don't want to have any software updates causing some kind of issues, some kind of outages during the migration. So we say from the very beginning, there are no software updates that are possible. This is out of question. Second point is the box right next to this in green, that our devices are running different versions. Because of different versions, we have or we see MQTT 3 and MQTT 5 both in use. So our new broker solution needs to support both protocol versions as well. Looking to the next one, from our self-managed MQTT broker, our backend services are interacting with it using shared subscriptions, which means that within the services, all of them subscribe to the same topic. Only one backend service instance gets the message. So we're load balancing in a round-robin manner within one service, and that also needs to be supported by the new solution. When we now look at all these requirements and the architecture, I would have a question for Andrea. Do you think that AWS IoT can actually support the requirements of this workload?
Thank you, Katia, for the valid question. I'm very confident on that. But before jumping into the solution, let me give you all an overview of what is AWS IoT Core and what are the features that it offers. First of all, when we speak about AWS IoT Core, it's a managed service solution that comes from AWS. And like all the managed services that we offer, we implement a shared responsibility model between what AWS does and what you as a customers are building on top. So we take care of the infrastructure, of the development, of the security aspects, on the scaling aspects of everything that you see that I will be presenting in a moment. We expect the same from you as a customer, to build your solution taking the same consideration in mind. If we look at the list of services that are part of AWS IoT Core, I will just highlight the one that are fitting with what Katia was presenting before in terms of architecture, customer architecture. And those services, capabilities are the one that are highlighted in purple. We start with identity service. This is the layer that helps with the authorization of devices against the solution. In this case, we have mentioned the usage of X509 certificates. This is an example of a scenario, but there are multiple alternatives that are available, from custom tokens that you can define and use from your custom identity to X509 certificate, as I mentioned. There is then the device gateway. That is the important layer to allow you to scale and connect all the millions of devices. So we had the example of 10 million devices. This is something that AWS IoT Core supports and scale nicely. We speak then about the message broker. This is the layer that helps in distributing the messages between the different consumers and publishers in a reliable and fast manner, as well as scaling to support the millions or billions of messages that you might have during your day. And I will not speak for the moment about rule engine and device shadow or device management, but I really encourage you to check the documentation, because they are just not topic for today's conversation and they would take a lot of time. So I close this part with the registry, giving an idea that registry is, as the name says, the place where you can manage the catalog of devices that you have and that you connect to the solution. So this is the starting point. Now, if we look and we take a close look at the capabilities or features that AWS IoT Core support for challenging migration, I would like to start with the first one being the custom domain capability. So what it brings is the ability for you to bring your own domains. If you remember the architecture presented by Katya, there was an important point. We don't expect the devices being able to change their firmware. So no firmware update possible. What it means is that those devices can communicate only with endpoints that they are already familiar with. And in order to migrate them, that same domain must be brought into AWS IoT Core. So you can register your domain, go through a validation step, and have the domain available. The second capability that we want to highlight is the support for MQTT. It's not just about MQTT itself, but it's the interaction between clients that speak MQTT3 with clients that speak MQTT5. This is fully supported. Of course, certain attributes, certain properties of MQTT5 that is extending the capabilities of MQTT3 will not be propagated to clients that just speak MQTT3. But just keep in mind you can combine the two in any form, client to backend, backend to client as well. And continuing the list, the usage of your own certificate authority. Also here, remembering the use case, we cannot change anything on the devices. So the devices have already an X509 certificate. Therefore, we need to be able to trust them when the devices connect with those certificates to AWS IoT Core. Also here, you can bring your own CA, so in the sense that you can register that CA into AWS IoT Core, go through the verification steps, and from that moment on, AWS IoT Core will trust the certificates connecting to it. These have been features that have been launched since, I would say, more than a few months. And what we are going to touch in this slide is the list of new features that have been introduced after November 2024. We start with the message enrichment with registry metadata. Why this is very helpful is because there are scenarios where you might want to obtain additional information associated to the device payload that was sent. And what you normally end up doing until the launch of this feature was to use a Lambda function or use some compute instances to retrieve this information from either registry or a DynamoDB table or any other sort of database. This feature allows you to store in registry the attributes and get them propagated in every single message that is sent by the device. How this effectively works, after you configure those attributes, when the device connects the first time, these attributes are cached at the broker level, and any subsequent message is enhanced with an MQTT5 user attribute property that can be consumed by the backend. The second feature that comes into picture is the thing to connection association. So what it means is that until today, it was very hard to perform a migration if a customer like you was having client IDs that were not matching the format of a thing name. And this was not helping with the usage of policies because the policies were using constructs that are bound to the thing name. With this new feature, it's possible to exclusively map a thing to its own certificate. So you can use multiple client IDs to communicate with the same certificate and still being able to reuse the same policies that are bound to the things. So very powerful feature for your migration. We move then into the next one, that is client ID in just-in-time registration. What basically offers this feature is already moving in the direction of authorization and validation. Until today, the just-in-time registration events that we introduced before us in the presentation of part of Katya, where the device connecting the first time to the broker gets automatically registered, this event was not included in the client ID information, so it was not possible to do that validation. With this new feature, it's now possible to receive the client ID and perform additional validations that are, from a security perspective, relevant. Speaking about security, I bring in two additional features which are very specific in the area of authorization and validation. They are both similar to each other, one extends the other. So if we start with the custom client certificate validation, here is a use case where at the moment in which the device connects, a Lambda can be triggered to do validation against the certificate that has been received in input and just give back a feedback, yes, no, if the device can connect or not to the broker. The extension of it is the custom authentication with X509 client certificates, which is in the direction of allowing you to do that same validation that I just mentioned, but extend it also with the indication of which policies you want to grant for the specific device at runtime. So look at it as similar as the custom authorizer that existed so far. Before closing, let me also mention an important enhancement that has been done at the level of AWS IoT Core that is about removing the requirement about the adoption of application layer protocol negotiation extension, so-called ALPN, in the TLS handshake when connecting to the broker. Until today, many customers were blocked when using the protocol with port 443 with X509 certificate in those devices where the device was not able to extend the TLS handshake with this extension header. Now this is not required anymore, so you can complete your migration just fine. Having said that, Katja, what do you think? Are we good to go?
Yes, I think I'm really convinced that all our requirements and everything we need is fulfilled by this possibly new solution. Now let's dive into how we actually would want to have this cloud environment to look like. So our target architecture is very similar to the one before. We have our 10 million devices. They are using Route 53 here, but of course you can use any DNS server of your choice. And the important part is that now we want to connect to AWS IoT Core instead of our self-managed broker. And from there on out, the backend devices, the API gateway, and the consuming applications, those stay the same. So this is the target that we have in mind. And the next important thing to discuss is the migration strategy. So it's quite ambitious here. We want to have it as risk-free as possible, same for also being very controlled. We want to have a minimal error surface and don't impact the customers that are interacting with those backend applications. And of course, you always need to be prepared for things going wrong. So we need to have also a fast rollback strategy. That sounds quite nice, but now let's think about how we can actually make this happen. And for this part, I would like to point you to that second video. So the second video is the one where we're going to walk through how this works for our architecture step by step, and just click on the reference link in the description below to have a look at that one. I want to thank you for joining us today. We are very excited that we had the chance to talk to you about this, and hopefully you have learned quite a lot as well. Thank you so much.
Thank you.